Hey everybody, this is Larry. This is day 24th of the January Leetcode Day Challenge. Hit the like button, subscribe, and join me in Discord. Let me know what you think about today's problem. We're finally at the weekend and we have a simple problem, hopefully. I'm not gonna lie, I don't usually peek, but today I'm a little bit ill prepared and I just saw a little bit. So we'll see how it goes. It is a medium. It's a weekend. Yesterday was a mess, so today hopefully we'll catch up a little bit on the rest. I don't know. I'm feeling a little bit sick and down and everything. Just everything like I don't know. Everything's been going on physically right now. So my apologies if I'm a little bit off. But today, let's take a look at today's problem. Then we have 1877 minimize maximum pair sum in array. You have pair sum A B is equal to A plus B. The maximum pair sum is the largest pair sum in the list of pairs. For example, if we have pairs 1, 2, 2, 2, 2, okay. It seems straightforward. Given away numbers of given length, pair up the elements such that, this is this is a greedy problem or greedy solution or a problem with a greedy solution, and the really you just have to prove it, which is a little bit tricky. The idea here is just the exchange principle, and if you haven't heard about the exchange principle, then or exchange argument, I think is actually. Then definitely, Google it up. But the idea here is that you make some argument about some local optimality of like, okay, well, let's just say we have A, B, C, D. And then the way that we're going to do it, I know that the code was short anyway, but I also just know this one because this comes up a lot for like other random reasons. But the idea is that you match, A, B, C, D this way, and assuming the A is less than B, is less than C, less than D, right? And here we do get to, pair them up, right? And the idea here is that, okay, well, we have A plus D, B plus C, right? And then the idea here is that, okay, well, if we do change it up, if we don't match it this way, and let's just say we change C and D, well, then what happens? Then you have A plus C, B plus D, right? And of course, because we know that B is bigger than A and D is bigger than C, this is going to be bigger than B plus C, right? But I guess you can, there are a couple of ways to say it. Maybe I said it like the poor way, but B plus D is obviously bigger than B plus C because D is bigger than C. And B is bigger than A, so that means that this is going to be the biggest of these four quadrants, if you will, right? But as a result, if you want to minimize the max, then this is going to give you a worse result than here, right? And then and that's basically the idea. And then if you want to just do it with more things, you just kind of think about it not recursively, but iteratively, I suppose, of like, okay, well, we have FED, right? And then now you could just, without loss of generality, you would just be like, okay, well, this is the same as whatever, so we just remove the C and the D, and then we've already done this argument, right? With different letters, but you get the idea. So that's kind of the way to think about it in a greedy kind of way. And it'll be funny if it just happens to be wrong, and I'm like, oh, I'm remembering a different problem. But that's basically the idea behind these kind of things. And I know that it seems like I'm hand waving it, and like I'm going really fast, I'm not. Look, I'm very direct and honest about this. I've seen this problem before, right? Not that I remember this problem in that way. It's just that, in fact, this kind of concept, this kind of idea comes up as a foundation for building tough problems, right? If you look at, if you think about how sometimes I am able to solve the hard problems, or maybe even a hard one, during the contest in like 5 minutes, well, it's because the hard problem sometimes consists of like 3 or 4 of these mini problems, if you will, combined together in some interesting way. And if you have to spend 10 minutes or 20 minutes on the mini parts, well, then you're not going to get the hard in time anyway. Because, maybe it's doable, maybe it's not, but it just takes a lot of time. And I don't know if this is interesting to y'all. Let me know in the comments. But I'm just going through my thought process about, that's why people practice. That's why, I'm fast at this, not necessarily because I'm practicing this particular problem or that I'm practicing or memorizing this. In fact, the reason why I remember it probably just because it comes up a lot, or maybe not a lot, but like, enough times, right? Like everything else, if you kind of see it a couple of times in tougher problems. You're just like, okay, yeah, I know this is true. So you don't have to prove it again. I'm obviously also on video, right? You're watching me. That's how videos work. But so I am explaining and slowing it down to explain it a little bit, maybe. But that's kind of. But like if I was solving it on a contest, I wouldn't have to think about it because there are times where like I would solve or I would attack a problem. I'd be like, oh, is this right? And I have to think about it, right? And that happens a lot too still. But there are times where I'm like, oh, I know this is right. So I just kind of skip to the next step, if you will, right? And that's what practice is for. And this is, I don't know, maybe that's just a long way of saying like, this is why, whatever, right? And there are a lot of ways to write it. I think the way that I usually like it is, whatever. Wait, the maximum of the maximum? Oh, no, the maximum. Okay, this is pretty weird, but okay, fine. Right, so we want the maximum, right? Because we already assumed that we minimized it, right? So that's why we want the maximum. And it'll be funny if it was wrong, because I'll be like, maybe I'm thinking of something else. But thankfully, not too embarrassing today. It's, it happens a lot, even if it did. So, but that's it. Obviously, there's going to be sorting. So there is a sorting, and that's going to be n log n. And that's it. That's all I have for this one. Let me know what you think. One thing I would, because this is a short video, maybe not that short, but it is short because I didn't really do that much. I'm just rambling. I've been playing this game, Nine Kings. Anyone play that game? I don't know. It's not a popular game, but it's one of those like, I don't know, kingdom building games maybe. I don't know. Anyway, let me know in the comments. That's all I have for today. Let me know what you think. Thanks for watching. Have a great weekend, everybody. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye bye.